Welcome back. In the last video, we worked on trying to build a model given some data. And now I want to go the other direction. Given a mathematical model, I want to try to answer some questions about the real world with this model that's already given to us. So in this example, I want to look at the average number of daylight hours in Paris. And it's given by the function d of t. In this case, t equals 1 is going to correspond to January, and t equals 12 is going to correspond to December. The first question is how many daylight hours are there in April? And so first I have to figure out what is going to be my input. What month number is April? Well, if January is marked as 1, then April is going to be 4. So if I want to know the number of daylight hours in April, that's going to be the same thing as looking at d of 4, which is going to be equal to 3.9 times sine of pi over 6 of times 4 minus 3 plus 12.2. Right? D of 4 means that I'm going to plug 4 in every place where I see that t. And before I go to the calculator, I'm going to do one more line of simplification because I see this 4 minus 3 there, and I know that that's 1. So this is really 1 times pi over 6. Really just pi over 6. And now that I have that simplified, I'm ready to go to the calculator and plug that in. I like to simplify a little bit first because it can be easy to put these in wrong in the calculator. So I like to do some things by hand before I go straight there. Okay, so 3.9. First, I'm going to double check that I'm still in radian mode because pi over 6 is a radian. Okay, I am. 3.9 and then sine of second pi over 6 plus 12.2, and that's going to get me 14.15. Since it's a real life phenomenon here, I want to interpret this mathematical answer in a sentence. So I want to say, what does this mean? This is hours. That means in April, there are 14.15 daylight hours per day in Paris. Okay, the next thing I want to think about is what is the maximum number of daylight hours and when does it occur, and what about the minimum? And to answer this, I might go to the graphing calculator. Then I want to think about what window I want to use to graph this on, because if I don't change anything, the default is kind of -10 to -10 in both directions. But since this is a real life phenomenon, maybe those values don't make a lot of sense. So let's see. I might want to do my input, my x values for like a year and a half. So I might go from -1 to 18. So -1 would mean give me maybe a month. Give me from December. Go back just a little bit so I can see my x-axis. And then 18 more months. So I would go year and a half forward. And then for my y's, I picked 0 and 24 because I don't know what range to expect these to be in, except for that there's more than 0 daylight hours in a day, and there's definitely less than 24 daylight hours in a day. So I think that'll give me a good range to look here. Awesome. While this is graphing out, I'm going to go ahead and copy this over here. It does something like this. And so I can see that I have a maximum in maybe a couple of places. Let's go ahead and calculate that maximum on the graphing calculator. If you were on Desmos, you'd be able to just click right there on your computer and you would see that point. On the graphing calculator, I need to go to second calc. And so second calc, that button up there. And then I'm going to try to find a maximum. And to find a maximum on the calculator here, first I'm going to click a button that is to the left of my maximum, and then I'm going to click a button or click a point that is to the right of my maximum. And then I'm going to say, yeah, calculator, I want you to guess somewhere in between there. So I hit equals 3 different times there. And when I do that, I get 6, 16.1. So my maximum is going to be 16.1, and it's going to occur when t is 6. Well, let's interpret it that real quick. When t equals 6, what month is that? January, February, March, April, May, June. That's going to be June. So the maximum number of daylight hours is 16.1 hours, and that occurs in June. What about the minimum? To calculate the minimum, I'm going to do a really similar process. I'm going to do second and then hit this calc button, and I'm going to go for a minimum now. And again, I need to tell my calculator, hey, over here, I am to the left of my minimum, and then I need to go find a point to the right. So I'm going to scroll over and then press enter, and then I'm going to press enter one more time so it thinks about it. And the point that we get there is 12 and then 8.3. And what month is that? Well, the 12th month is December. So the minimum is 8.3 hours, and that occurs in December. Our next question is, what is the average amount of daylight hours? So I see that sometimes I have a higher amount of daylight hours and sometimes I have a lower amount of daylight hours. And I think my average is going to be the amount that's kind of right in the middle there, right? So one way to think about that is to actually average our minimum and our maximum. Our minimum is 8.3. Our maximum is 16.1. And to average two numbers, we're going to add them up and then cut them in. So let me put that in my calculator. If I do 8.2 plus 16.1, I get 12.2. So this tells me the average amount of daylight hours is 12.2 hours. There's one other thing that you might notice here. Maybe you see this number 12.2 and go, hold on, haven't I seen that number before? And that's the same number there. If we think back to the previous objective, and we think about the different translations, this plus 12.2, that was going to move my graph up 12.2, and that represented the midline of the graph. And the midline should also be the average. Like if I go up and I go down and then the midline is in the middle, then that should be the average amount. So we actually could have fast-tracked this by, instead of taking the average, just taking that number right there. There's one last thing I want to do here is I want to calculate D of 2 and D of 12, and I want to interpret those results. So first I want to think about what each of those mean. So D of 2 is going to be the number of daylight hours in what month? Let's see. January, February, right? The second month is going to be February. What about D of 14? It's still going to be a number of daylight hours because it's the output of my daylight function. It's going to be in month 14, which last I looked at a calendar, we only have 12 months. So what does that mean? Well, I guess we could think of month 13 as being the next January, and then month 14 as being the next February. So these are two different Februaries that we're looking at here. Okay, so let's calculate them. So D of 2 is I'm going back to my original function way up here. D of 2 is 3.9 times sine of pi over 6 times 2 minus 3, and then plus a 12.2. And D of 14 is going to be 3.9 sine of pi over 6 times 14 minus 3 plus 12.2. Okay, I went ahead and already plugged those into my graphing calculator. On this one, I get 10.25. And in this one, I get 10.25 as well, which was the same number. So I want to pause and think if that makes sense to get the same amount there. Well, both of these represent the daylight hours in the same month, just in different years. And daylight hours is something that should repeat. So this means not just in this February and next February, I think every February we're going to get 10.25 daylight hours. This February, next February, the February after that, no matter what, we're going to get about 10.5 daylight hours. All right, so this is an example of taking an existing model and interpreting it into real life answers. And what I really want to point out here is that in addition to some like math answers, like this is a point, we also have a sentence interpreting these. A lot of times when we start to apply real life phenomenon into real life, our answers are not just going to be a mathematical calculation. Our answer is going to be like a sentence that explains what that mathematical calculation has to do in the context of this scenario.